Hello and welcome to Lecture 31, Inside 3D Models. This is the HTML5 lecture series at SNHU. I'm Tom Adamson, visiting professor. Let me get a sip of coffee here. Now, this lecture is going to be divided into three parts. First of all, there will be some basics. And then there'll be where we are now. And then we will have what to expect in the future. So the reasons why I'm writing this out this way is that when we start out with the basics, you may already know this, and you might say, oh, so I know what's going to be in this lecture, and I'll just skip it. Well, if that's the case, just fast forward to this, and if you still know this, make sure you at least cover this part right here, what to expect in the future. So what we're going to do now is that we're going to talk about how 3D models are actually made in the computer, how they're stored in the computer. And basically the way they're made is if I have a cube, which is probably one of the simplest 3D models. If this cube were a GIF or a JPEG or just an image, that's always going to be like that, the computer could know everything about it and just put that stuff up there. But let's say this cube is going to be something that's going to be rotating or something I can move around and what have you, where its orientation is always going to be changing like in a 3D model. The computer, if it had to keep all the information about what was on all these faces and what have you, it had to keep all that information at the same time, it'd be hard for it to do that. So the way the computer does it is that it looks at these points. If I'm doing a real 3D model, it looks at these points. And how many points do we have here? We have 4 up here, and down here we've got another point here, and another point here, and a point here. These points are called a vertex. So I see on this cube I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 vertices. This right here, the line that joins these vertices, is called an edge. E-D-G-E. And this right here, this plane, this right here is called a face. Now, here's the information that the computer stores. 3 dimensions. I'm going to take, this is my x-axis this way, this is my y-axis up this way, this is my z-axis out this way. The computer will store information about the 8 vertices. Like for example, it'll take this first vertice here, and let's say everything is a unit of 1. Let's start with the vertice down here. Everything's a unit of 1. So start with this vertice and it'll say x, y, and z. That's how it stores the coordinates. So say, okay, the first vertice, number 1, that's going to be equal to 0, 0, 0. So the computer knows to draw that vertice right here. The next vertice, let's say this one over here, number 2, that's going to be equal to, what is x? That's going to be a 1. What's y? That's going to be a 0. And what's z? That's going to be a 0. And then for the next vertice, let's say the next vertice is this one here, vertex 3. The x on that one is going to be a 1. The y is going to be a 0. And the z is going to be a -1. Because it's going back this way, and so on. So what it does is stores information about these 8 vertices for this cube. Now, when this is rendered, when this comes through the system that allows you to see the 3D object, the rendering engine looks at this and says, oh, I got to draw lines here, and not only that, now I have to construct faces. So what I'm going to do now is I'm going to go over here to the board, to the screen. I need to get on the screen here, please. Okay. And this is how I construct a face using this method. If you notice, every one of these shapes right here, they look like they're curved, but they're not. They're really just flat surfaces. And the reason for that is because the computer is storing information just about the vertices. That's all it's showing information about. We're going to stay on the screen here, and I'll illustrate using one of my favorite programs to illustrate with this stuff. And what I'm using here is I'm using Blender, and I'm going to come in here on Blender and I'm going to put add, and see, I'm going to add a sphere. So I've got a sphere here in Blender, and the sphere appears to be round. You say, yeah, well, it's a round sphere, but actually it isn't. I'm just going to come in here and do this, and then I'm going to tab into this here. If I look at this, all of these faces that are on the sphere, they're all flat. The only thing that curves is right at the edges. Let me show you what I mean. I'm going to come here on this one. I'm going to right click and I'm going to extrude it. Okay, and I'm going to bring it out. And then I'll accept it here. I'll move it around. Now if you look at that surface is completely flat. In other words, what the computer has done here is that it's storing these vertices right here, but when it generates the face is completely flat. And the reason for that is because that saves computer space. If I go up here on any of these that look like they're curved surfaces, I'll see that they're not. We're going to stay on the screen here. Let me scroll up here. Now let me have a look. Here's right near the top of this dude. So I'm going to come here. I'm going to right click to select it. I'm going to extrude it and bring it out. And if you notice, it's flat. And here, let me come to the next one here. I'm going to extrude it and bring it out. It's flat as well. So the only curving that takes place is when these edges meet, and then the surfaces will be different. If you notice, this has 3 sides. These are called polys because poly means many. This would be called a tri for a triangle. This would be called a quad because it has 4 sides. And you may not be able to see that from here, but it tells you that the vertices on here are 493 vertices, the edges are 1014, and the faces are 523, and the tris are 982. And the reason why the tris are not double the faces is because there's already tris here, okay, on this one right here. So the more of these that I have, the rounder the sphere will look. But the problem with that is that I now need to keep more and more information about where all these different points are, and that starts using resources. And if I'm doing this in a game where things are moving, that'll really start slowing down my game. So I'm very concerned about, let's go back to the board here, please. The poly count, P-O-L, poly count. What I want to have on my mesh, that's what this is going to be called when I put these together, I want to have a low poly count. And the reason why I want a low poly count is so that I don't use so many computer resources and slow things down. However, I need to have a balance. The lower the poly count, the less real, so to speak, objects look. The higher the poly count, the better they look. Okay, we're going to go back to the screen now. Back to the screen. And I need to illustrate something else. Come back to the screen here. Here's a face that has a relatively high poly count. And even though when you look at this in 2 dimensions, it looks like these are curved surfaces here, they're really not. If you look at it flat on, you would see that these surfaces are flat. And it does have a relatively high poly count, but stay on the screen here and I'll show you something else. Okay. I'm going to come down here to, see, where is that? I'll find it. Oh yeah, I found it. Okay, and let me sort of zoom in on this here. Okay. Here, for example, is a mesh that has a relatively low poly count. Here's a mesh that has a very high poly count. This shows a lot more detail than this one up here. However, in a game, this high poly count one would be very hard to render and have it move around and be in action and what have you. So here's how modelers fake things out. What you can do is that you can take the surface of this and you can unwrap it. There's a way in the program of unwrapping it and making what's called a UV map. And the UV map will look like this. You're taking the whole face, you're unwrapping it, and you're laying it out flat. And when you do that, it becomes a GIF or a JPEG. And then you can color it, you can do whatever you want. Generally, people will use Paint Shop Pro to do that. And so here's the same thing again. Even though these images here are tremendously different on resources, this is high resource, this is low resource, these JPEGs or GIFs use about the same amount of resources. So here's what modelers will do. They'll make a high poly model like this so it looks good. They'll unwrap it, save this image, reduce the poly count to this, and then take off the old image and put this high one on here, even though this here has about the same amount of memory as that one. So now it fools the user into thinking, oh, this really looks good, and it will look good. Let me show you what I mean. If I scroll back up here, and you saw me pass it, right up here to this guy. For example, here's a dude that, if I look at his poly count, he's got a very low poly count here. And he looks pretty rough. And here he's got a low poly count here. And here's his weapons that he's using. And you can look at these and they look like toys. However, someone made a high poly count of this as well as his weapons, and then unwrapped it, and then went into Photoshop and colored it, and then reduced the poly count, and then put the high poly UV wrap back on him. So if you look at his machete here, and you see the UV map's been put back on, it looks much better. Same way with his weapons, and the same way with him. He doesn't look like he's a low poly now, although he really is. So that when he's animated and stuff, the only thing that's bending here are what you need to bend. And now he looks, quote, realer, but he's not using as many resources as would be used if he actually had a high poly count. So we're very concerned about the UV wraps. That's called the UV wraps, or a flat UV image. And so we use Photoshop along with a 3D modeling tool that'll make the mesh, and then we use Photoshop to unwrap things and then make them all pretty, and then reduce the mesh count and then put it back on, put the wrap on from the high mesh count. Okay, we're going to stay on the screen here. and I'm going to show a demo. This demo was made by Angela, who's a character artist, and she made the characters for a movie that was created in Blender, and the name of the movie was called Centel. And this will show you some of the tricks she used to make the major characters. There's a mesh of her. This right here is the UV wrap that was taken off of that mesh of her that you saw. She took it off, and then she used Photoshop or whatever to paint it, to make it all nice and pretty like you see it now. And then she kept her mesh, and then she took this and wrapped it back on. And that's how you saw the nice face that you had. And again, notice the face was made out of polys. The head itself was made out of polys. This is a character called Centel that she created for the movie. All of the stuff and animation, everything you see here was done in Blender, which of course is a free open source 3D modeling and animation tool. That's called the T-pose. And there again you see the mesh. There's the mesh for the fingers, and there's the wraps that were used on the main character called Centel. This was the UV map for the face, UV map for the upper torso, UV mapping for the fingertips. There's the tattoo that the main character had on her. What's happening here, as you see the lips and mouth moving, those are, they're using those as what they call shape keys. And actually what they're doing is that they're using a program that moves the mesh around, moves the points in space around to give the illusion that the character is actually talking or having expressions. This is doing the lip syncing in Blender. Okay. I think you have enough of a background on meshes now. I'd like for you to stay on the screen here. And I want to come to using Google SketchUp. Okay, I'm going to come up to the screen here. This is Google SketchUp, and I'm using it to illustrate something. Google SketchUp has two versions. It has the professional version, which you pay for, and it has the free version, which is what I'm using here. Even though this is a free version, it does have restrictions. It's not open source. So if you're using the free version, you want to really make sure that you read and understand and follow what the restrictions are. I can do things that I'll be showing you here in Google SketchUp because I'm a bona fide instructor here at this institution, and I'm using this for educational purposes. So it's not as restrictive if I'm using it for non-commercial purposes. But when you download and install your version of SketchUp, make sure that you read and understand and follow what the restrictions are. Okay, what I'm going to do here, we're going to stay on the screen. I'm going to go into the SketchUp library, and I go here, I go to File, and I go to 3D Warehouse, and I put Get Models, and I'm going to search for a car, C-A-R. Okay, that's pretty straightforward. And when I search for a car, first car I see here, they have hundreds of car models, is a Porsche. And all these models were made by users. And I'm going to take and get a 3D view here. There's a 3D view of the Porsche. And down here, the person who made it tells about how he made it and what have you. And if they have any restrictions on its use, I'm going to download the model. And it says load directly into your Google SketchUp model. Yes. So now what it's doing is downloading the model and putting it right into my Google SketchUp scene. And there it is. There's the Porsche. And the Porsche is actually a mesh. And if I look at it, I can even see it has an interior. And that's really pretty cool. Wow. And this is like, this didn't cost me anything to get. So let's see what I want to be able to do. I'd like to be able to take that Porsche and make it so that I could see and move and animate that Porsche through a web browser. How can I do that? Well, the first thing that you want to do, you want to come up here to File, and you want to come up here to Export. I'm going to export this 3D model. And so it says, where do you want to put it? Well, I already made a folder called car. And if I look down here, it says collidafile.dae. That's a file type for storing three-dimensional instructions for a mesh. I'm going to call it car, C-A-R-D-A-E. And I'm going to put export. Okay, so it's exporting now. And then I'm going to come back here, close this, and I'm going to look in that file called car. And inside the file called car, I see I have a folder called car. I also have an image here, a JPEG called print2. Don't worry about that for now. I'm not going to be using that for anything. And I see that I also have a car DAE. The DAE is a file format for giving information about the 3D mesh. And look, that's Notepad. Let me look in here in the car. You know what these are, these images here? These are all the UV wrappers that the car uses, that the car model uses. These are the wrappers that go around the car model. Okay? If I look back here, I see car DAE. I'm going to double left click on that and see what that is. These are the instructions to how to make the mesh for the car. And let's see what those instructions are. Good grief. Did you see what these instructions are in? They're in XML. The instructions for making this mesh, this complex looking car, are all given in an XML document, which means I can use Notepad to modify the 3D mesh. Hey, that's fantastic. So that's good. I learned how to do this. So what I'm going to do, I'm going to see now, how can I make this thing work in a browser? How can I take this definition along with its UV wrappers, put it in a browser, and actually use my keys and manipulate the car in a browser? So far, I haven't done much work on this. And I already have a Porsche. Okay, so I'm going to close this guy here. And I'm going to come over here, and the next guy I'm going to open is this. I'm going to bring this over here. And I'm going to come here. This is actually up on my server. And I've got something here called My Stuff, and I got something here called My Car. Let's look at My Stuff first. Okay, there's My Stuff. All right, now let's see, how can I get, is this what I'm looking for? No, that's not what I'm looking for. I'm looking for this, and let me see if I can get some notes. Yeah, here we go. That's what I'm looking for. Okay, I'm going to go back to here. All right, On this one here, what I've got is I've got a horse, D-A-E. This horse I got from SketchUp. And I know that this is nothing more than an XML document. What I've got here, these are the wrappers for the horse. This right here is the index. That's my main web page. That's HTML stuff. This right here, this JavaScript, this helps me animate the horse. That's all this does here. If I take this and I look at it and I go to edit it, it's nothing more than a text file. This should all look familiar. It's a doc type HTML, which means it's HTML5. And here's what I'm doing. This is my JavaScript. And what I'm using here, I'm using GLGE as a library to help me manipulate things that are using WebGL. And this is free to use. Okay, I can download it and use it, glge.org. And I come down here, and this is what I'm looking for. I'm looking for the physics mesh fraction. And there's my Collida document. Why is it a document? Because it's an XML document. Horse DAE, that's what I want. This is the scale of horse DAE. Okay, so I can go ahead and close this. I can see what's in there. And what I want to do now is I want this. And I want my stuff, which is right here. And now, if I'm very, very patient, I can get the horse to come in. It'll take a while. There he is. I just saw him. Come on, horsey. He's got to get his wrappers on. Okay. And there he is, in 3 dimensions. And all of the mesh information was taken from that XML file. I'm using my arrow keys to move them around, and that's from that JavaScript file that I have there. So the horse uses its wrapper, and I can click on it and I can bring the horse around here, okay, so I can see him better. And there he is in all his glory, okay, like that. All right, so the other one I want to look at is, let me come over here, and I'll come up here, up one level, and I'll look at my car. I'll open that. And what I did is I uploaded that DAE file that I downloaded from SketchUp. That's the car DAE. And we know that that is nothing more than an XML file. And there's the wrappers are all contained in this folder here. Okay, they're all JPEGs. That's what I'm going to wrap it with. And then the index, it should be the same as the other index, except it should be calling for the car DAE right down here. There it is, car.dae, and that's the scale. That's the size I want to make it. So I'm going to close this, and I'm going to come over here now to, to my car. Okay, and there's my Porsche, right out of SketchUp, and I can move it around, animate it. Okay. The wheels are a little bit buried, and that's because of where I have the coordinates for the plane. So now this is being played through a browser. I can animate it through a browser. It's simply a DAE file that does it, DAE document, which is nothing more than an XML file. That's all it is. Okay. All right. Here's the next thing I want to see here, is this guy. Now, let me explain what this guy here is. This is using another program in order to define a 3-dimensional mesh. I'm going to move this around. It has a wrapper on it. Notice what it's using. It's not using XML files. It's not using what we were using on the other one. It's using a .json file, JSON. That's JavaScript Object Notation. What is that? Well, let's see. What I'm going to do, it says that I can take any of these files, download them, and then put them into here, and it will change what the object is here. And here's how I do this here. Okay, so we're going to have a look at it on the monitor screen. So if I come over here and I hold down my Z key, I can zoom it. I'm zooming out, and this is how I rotate it. And I see it's like a three-dimensional vise or something like that. Okay, and I'm going to take a JSON file, download it, and there's my JSON file coming right down here. Then I'm going to take it and I'm going to open it, see if I can open it, and I'm going to select the program to open it with. What do you suppose I can open it with? Any idea? Let's try Notepad. Okay. And let's see. This is the one, a JSON file that defines the 3D object. And look, there it is. There's all my vertices right up here. My face count, my vertex count, what have you. And it's storing all the information about where everything is. Well, that means if I really knew what I was doing, I could modify this using Notepad. But the point is that what a JSON file is, and we're going to talk about JSON files in the next lecture, it's nothing more than a text document, just like the other stuff. So I'm going to drop it into here and see what happens. Whoops, there it is. Come back here. All right, let's see. Whoops, wait, I just had it. Don't go away. All right, and there's my other one. Okay. Now this is a different one that was there before. So the point of this is that I have other formats that I can store these 3D meshes in, other than the one that uses the Kaleida. I can also store them in JSON documents. Okay, so let's see where I want to go next. Here's something that you may really want to pay attention to that's coming down the road. And that's this guy right here. This is ChromePad 2.2. And ChromePad 2.2, it's at www.files.croar.net, and it's ChromePad. ChromePad is being developed by a group of programmers to be able to have an equivalent of Photoshop right through a browser, where you can save your images and what have you. In Photoshop, most people use 20% of the features 80% of the time. Okay? This one right here has most of those 20% of the features. And what you can do is that you can open your image, you can upload an image and work on it, or you can create a new image, and then you have all these different things here, just like you have in Photoshop. The difference is you're doing it through a browser. The browser is now the platform. There's nothing that you have to install. And of course, this is open source, and it's free. So since it's open source, if you know what you're doing, you can modify it. This is constantly being improved and updated. Last time I looked at this, there was a lot of features that it didn't have that it does have now. You've got your gradients, your filters, your adjustments. Stay on the screen there. Just let me give you an idea of what you've got there. I'm going to create a new image, and it says what size do you want. Hopefully this should look familiar to people. I've got here gradients, all different kinds of gradients. I got filters. I've got adjustments, all different kinds of adjustments I can make on it. I've got different kinds of patterns. I got images I can do. I got edit. Then I got file. And then when I save the file, I can save the file right on my desktop as a JPEG or a GIF or whatever it is that I wish to use. So this is really one to keep your eye on because it is being developed, and you can see what's going to be happening down the road with this. Okay, the other one that I want to show you that really has some merit is this one right here. And this one, this is mrdoob.github.io. This one is incredible because what it does, I'm going to reset this. It's going to say okay, because remember where I left off last time, so I reset it. This one here is constantly being improved and updated. And fundamentally what it is, right through a browser, it allows me to create 3D environments. 3D environments, just as if I had one of those 3D editors. And I can save that 3D environment in different formats, like JSON could be one that I could save it in, and then put it up on my web browser, and I can have these things animated and what have you. I'm going to give you some just brief illustrations because I could spend a couple of lectures on how to do this. But what I'm going to do is I'm going to add a three-dimensional object there. What I'm going to do is I'm going to add a cube, and there's my cube right there. And the cube looks dark, and the reason why it looks dark is because I don't have a light. And if I click on the cube here, there's all kinds of information about the cube. Okay, the number of vertices that it has, its width and height, and so on. The material I can put on it, bump maps, specular maps, light maps, and so on. What I'm going to do now is I'm going to add a point light. So here's my point light. I bring it out here. And now notice it's lighting up the cube. Okay, just like a good point light should. I'm going to move it over here. Okay, like that. And then what I can do with the cube, if I wish, I look here on this right here, and I see there's my point light and there's my cube. What I'm going to do with my cube here is I'm going to put something on the face. And let's see, how do I do that? I'm going to map it. I'm going to choose a file. And that's why I chose that file that was in the car. And I don't want the spaceship. Let me come here to my desktop. I'm going to look for car. Didn't I have it as car? That's probably going to be over here. There it is, car. And whoops, there's car. Come on. And this is what I want, that guy. I'm going to open that, and I'm going to now do this. And there it is. You see it on there now? Okay. There's my image. That's right on the cube. Pretty cool, huh? What I can do is that I can come here and I can change this background color. Let's see. I'm going to change this color here to a black, but okay. So now I can see it a little bit better. And then I can come here on the cube, click on the cube. I can move it up, like so. I can do things like I can rotate it, like so. There's the image that I put on it. Rotate it this way. I can do things like enlarging it. I can make it come out this way or that way. Okay. Now I can also take other things. I have like a sphere. I can merge them together and what have you. I can put a color on the sphere. Let me put here, I'm going to add a sphere. There's my sphere there. It really doesn't look like a sphere, but it is. If I bring it over here, you'll see it. There's my sphere. And then what I could do with my sphere is I can come down here and I can put some material on it, and I'm going to color it. And I'll color the sphere, say, a nice blue color right about here, and put OK. So now it's colored with a nice blue color. There's my sphere. I can move around here like so. And I've got the sphere intersecting with here. The thing about the sphere now is I can change the different kinds of things. I can change its shininess. I can change the number of segments that it has. I can change the materials on it. I can change the emissive color to specular color. I can make it shinier. I can make it look more like metal, make it more look like plastic. And like I said, I could spend probably a whole lecture on just how to use this. So on this one here, you want to make sure that you know you go to mrdoob.github.io. It's 3.js editor, and he's using 3.js in order to make this. So down the road, what's going to happen as this gets improved. Down the road, you're going to have a 3D modeling program that you can use for free right in a browser, and it's made to be used for browsers, and this is written in HTML5 stuff using 3.js, which uses WebGL, and this is going right to my graphics card. Okay, stay on the screen there, please. Okay, the next thing I'd like to show you is this one here. And this is on blogs.msdn. And what this one here is that this is written for how to do a 3D soft engine from scratch using C#, TypeScript, or JavaScript. Of course, we're going to use JavaScript on this. And he takes you through step by step on how to do this. But what's important is that he shows you what you should know before you start taking this course. The first thing you should know is worldview and projection matrix. And you click on that, and it will take you to a site that teaches you how to use mathematical matrices. What a world matrix is, object space, how to do rotations mathematically, what these mathematical things mean. These are things we were talking about before. Knowing this information at this site will help you become a developer, not just a user. And I go here to his next one, and he says, you should know this one here, cameras, you should know transforms, how do you do transforms, and he takes you, this is how you do transforms, how you use more math, and also he'll show you how you do the programming. So this one here is a very important site to use, especially if you're going to be wanting to learn what it takes as a developer. Okay. All right. Staying on there, I'd like to show you some of the future stuff, and I've got that in my notes here. Just bear with me. I have the links down here, and let's look at ARC3D, ARC3D. Okay, I'm going to look at ARC3D and see what that is. Here's this site. See what ARC3D is. ARC3D, Automatic Reconstruction Cloud. This is the future. What I can do with any object, all I have to do is take multiple pictures of that object. Just go around the object taking multiple pictures. Doesn't have to be any specific distance, doesn't have to be any specific angle, just as many pictures as I can. Upload those pictures here, and you know what it'll do? It'll create the code for a 3D model. And then all I have to do is download that code, and I can use it in my HTML5. And then I can use animation files to animate it if I wish. ARC3D, Automatic Reconstruction Cloud. And cloud means the environment. It doesn't necessarily mean the cloud up on the internet. Okay. All right, the other one I wanted to show you is MeshLab. So let's look at MeshLab. M-E-S-H-L-A-B. What does MeshLab do? And here is MeshLab, M-E-S-H-L-A-B. Now, MeshLab looks real technical, and it is real technical. MeshLab is free. It's an open source, portable, and extensible system for the processing, editing of unstructured 3D triangular meshes. And what you can do is it'll import any of these different kinds of 3D programs. Okay, there's Kaleida, that's the one that we've used before, and it'll export it to this, so you can use it to translate from one 3D file format to another 3D file format. It'll clean up your mesh. It'll remesh your files. It'll colorize and inspect filters. It'll do interactive mesh painting. It'll do scanning tools. And it goes down and down the list that it'll do. MeshLab is great for cleaning up your meshes and making them so that they're more usable, especially where you're concerned about what the poly count is. So don't overlook MeshLab. Lab. It's technical to use, but again, this is what developers use, is Mesh Lab. Okay, staying on the screen, we have another that's called point clouds. That's point clouds, and then the other one I wanted to see was Babylon. Yeah, let me show you Babylon first, if I may. First, what Babylon can do. Babylon uses a browser. I'm looking at it through a browser. This, of course, is a video of it. But one of the things that Babylon has, it has a good LOD, which is level of detail. The closer I get to an object, the more detailed it becomes. And what it's doing is that it's loading itself and what have you, and giving you these videos. And if you look closely, the closer you look at something, you see, you get more detail. And that's really amazing. And all of this is done through a browser. This uses Babylon, and Babylon makes it so that it's easier to use the WebGL. Just to give you some ideas, and Babylon, of course, is anyone can use Babylon. So it's loading this one now, and notice on the car, notice all the reflections of the glass and everything. I mean, how real does that look? Isn't that phenomenal? And again, it's being done through a browser. It also has physics in it. Notice he said collision, and here's the inside of the car. I mean, this is phenomenal stuff. It's just incredible. So Babylon's another one that you don't want to overlook. You got GLGE, and you have Babylon, and you have 3JS. And so this is the inside of something. Okay, maybe it hasn't even been created yet. Okay. So you saw Babylon. Okay. And let me come here with my mouse. Right here. And I'll get rid of Babylon. And here's PLPC. PLPC is open source, and what it is that it's a point cloud library. And let's see what I can do with it. Find out how. Reconstruct your world, okay. This tells you how they do it and what have you. Let me see what this is. This is not the file that I was looking for, but you'll get the idea. Basically, here's what PLPC does for point cloud. It uses the Xbox 360 Kinect, and so what it does, it looks at the cloud, which is the space out there, and then by using that, it starts making points. As you can see here, here's somebody's couch. Here's a lamp that's by the couch. And from just looking at those points and moving around a little bit, it starts making a 3D model of it on its own. And the reason why they're using this right now, PLPC, is they're using it so that a robot can find its way around a room without bumping into things. That the robot inside its head can start constructing a 3D environment of what it's looking at. But here's the point. The point is that this technology can also be used to make 3D models that you could put up on your site, your website. So you don't even need a modeling tool. All you need to do is see what it is that you want and then use Kinect to do it, and you can make that 3D model and then bring it into something to modify it or whatever you want. So this right here, this becomes a very important tool that's being developed for the future. Let me see if I can find just one more thing on this. Let's go back to the board here. I would like to wrap this up. The things you want to look at and keep abreast of are these major three things here. ARC 3D, ARC 3D. The other one is MESHLAB, MESHLAB. And the other one is PLC, and that's for the Point Cloud Library. This is the one that's being developed for robotics, but it's the one that can also be used in our HTML5 stuff. What we're going to be doing on our next lecture is we're going to be covering what is JSON, J-S-O-N, because now we can see the importance of JSON, because JSON can be used to store information about 3D models. JSON stands for JavaScript Object Notation and allows me to keep an array of objects in an object and then convert all that to a string, believe it or not. Okay, that's it for this lecture. Thank you for attending.